Welcome back to AI on AI, the show where we peel back the layers of research so business and tech leaders alike walk away with actionable insights. Today, we're tackling natural thoughts and the science of distilling reasoning traces.
Delighted to be here. Quick background. I run strategy for a Fortune 100 manufacturer, so I spend half my time asking, how do I get a 7B model to reason like a 70B without mortgaging the GPU farm?
And I'm here with the Deep Tech Lens. I've led the data curation workstream on 2 open-source LLMs, so I'm itching to dissect those selection strategies.
Likewise, I build RLHF pipelines at scale, and this paper pokes every assumption we've had about less is more.
I'll bring the academic angle. My group's focused on meta-reasoning analytics, labeling 60-plus reasoning strategies per sample.
And I wear 2 hats. Cloud cost optimization and model deployment. My KPI is dollars per coherent answer. Ready to weigh in on inference time efficiency.
Perfect. Let's kick off with the 30-second synopsis. What's the core punchline of natural thoughts?
In a nutshell, they show that blindly scaling high-quality reasoning traces, up to 500,000 samples, keeps paying off. That's counter to LIMO and S1K, which preached that 1K cherry-picked traces were enough. Exactly, and they unpack why. Diversity of reasoning primitives, not topic variety, is the catalytic ingredient. Think of it like seasoning. You don't need 50 dishes. You need the right mix of spices in each.
To add, they also propose mixed System 1, System 2 distillation. Train some samples with full chain of thought, and others with only final answers. That shifts the efficiency-accuracy frontier.
Before we double-click on the tech, business leaders love numbers. Give me a concrete ROI example.
Sure thing. We replaced our proprietary 34B parameter model in a factory layout planner with an 8B student trained on 100K natural thoughts traces plus disagreement filtering. Planning runs dropped from 87.7 to 22 cents per scenario with only a 1.1 point hit in pathfinding success. That's an annual savings north of $6 M.
And because of the mixed System 1, System 2 recipe, inference latency fell by 41%. For a consumer chatbot we run, that shaved 300 milliseconds off average response time. Users don't see the supply chain spreadsheets behind it, but they feel the snappiness.
Nice. Now, let's zoom in technically. Expert 3, can you walk us through the disagreement-based difficulty sampling?
Sure, they take 2 teacher models, DeepSeek R1 with full COT and Llama 3.3 without COT. If the models disagree on the answer, they tag the item as hard. During SFT, they force System 2 traces on those, System 1 on easy ones. That creates a curriculum where the student spends compute learning to think only when necessary.
We measured that trade-off ourselves. Entropy of logits on easy items dropped 12%, while hard item entropy remains stable, indicating the student selectively reallocates capacity. That's effectively an adaptive computation time mechanism, but implemented in the data, not the architecture.
Kind of a data-driven version of the old, anyone can write code that a computer can understand. Good programmers write code that humans can understand mantra.
Exactly, except here humans are GPU schedulers.
Ha! And from a CFO's angle, that's gold. Pay for thought only when it's valuable.
Let's tackle the less is more controversy. Why did small curated sets plateau?
2 main reasons. First, LIMO and S1K focused on math and coding. Reasoning primitives were homogeneous, like teaching chess with only king and pawn endgames. Second, over-optimization on token-length distribution created a selection bias. Right, they inadvertently filtered out mid-length traces. Those are rich in decompositional steps. Natural thoughts kept that mid-tail.
And remember the 80-20 heuristic? Here, the 20% of traces with 5-8 unique strategies deliver 80% of the gains. They demonstrated that empirically.
For the practitioners listening, that means when you crawl or generate reasoning data, log meta strategies, and keep that sweet spot. Don't just chase length.
Speaking of length, the paper's figure 2 on adaptive inference was eye-opening. Expert 5, break down the numbers.
With pure System 2 distillation, average answer length on GPQA Diamond was 8,740 tokens. Switch to difficulty-based mixing and no-think prompt. It plummets to 799 tokens, yet accuracy only dips 3%. That's a 10 times reduction in token bill.
Translate that to dollars. At 30 cents per million tokens, a million queries drop from $2,600 to $240.
Not pocket change. Now, Expert 2, any implementation gotchas?
1. Sequence length limits. They trained with 16K context windows to retain full COT. Teams with 8K hardware need gradient ACM tricks or smart chunking. Another is annotation cost. Labeling reasoning strategies at scale isn't cheap. We've mitigated that with zero-shot annotator LLMs plus HDBScan clustering to flag low-variance examples. Cuts manual review by 70%.
And ironically, you can bootstrap, distill a mid-tier student, then use it as the annotator, self-improvement loop.
A quick sidebar, Sun Tzu said, "He who knows when he can fight and when he cannot will be victorious." Feels like mixed distillation embodies that. Think hard only on tough battles.
Love that analogy. It also surfaces a contrarian view I hold. The industry is over-fixated on test accuracy. For my business, inference time dollar cost per useful insight is the real North Star.
I'll second that. In ad ranking, we found a 0.5p accuracy trade-off was acceptable if latency dropped below 100 milliseconds, because user engagement went up 3%.
I hear you, but there's a caveat. In medical triage, that 0.5 PT could be life-critical. You'd want the model to auto-select System 2 more often in that domain.
Which brings us to controllability. They append explicit instructions like answer directly without thinking. Simple but effective steering token.
Yet there's a lurking risk. Malicious prompts can override that and force disclosure of private COTs. We need policy filters to sanitize reasoning traces.
Good point. Security layer is mandatory. Let's pivot to future implications. Where does this research steer the roadmap?
First, data marketplaces. Imagine trading reasoning diverse datasets tagged by strategy counts instead of just topic. Second, we'll see smaller edge models with reasoning abilities, enabling on-device analytics in, say, manufacturing robots.
Strategically, enterprises will benchmark compute-aware reasoning. CFOs will ask, what's our precision per watt curve, and treat it like a PE ratio.
And cloud vendors may price burst compute for System 2 spikes. Microsurging capacity only when the model requests deep reasoning.
On the research side, the next frontier is on policy distillation. Off-policy was easier, but matching teacher logits under student-generated prefixes could yield further gains.
Plus, richer annotations beyond strategy counts, tagging cognitive biases, checking for overthinking loops.
We're nearing time. Rapid-fire advice. 1 sentence each. What should a tech leader do tomorrow morning?
Instrument your training pipeline to log unique reasoning strategies per sample. It's a low-hanging diagnostic.
A/B test mix System 1, System 2 prompting in production. Measure token savings versus KPIs.
Prioritize difficult question selection via model disagreement. It's more sample efficient than obsessing over domain coverage.
Negotiate cloud contracts around peak token usage. Show vendors your efficiency graphs to get discounts.
Present the CFO with accuracy per dollar, not just accuracy. Shift the success metric narrative.
Fantastic. Data is the new oil, they say, but as Peter Drucker reminded us, efficiency is doing things right. Effectiveness is doing the right things. Natural Thoughts teaches us to do both. Thanks to all our experts and to you listeners. Until next time, keep your thoughts natural. Welcome back, everyone. Part 2 is all about rolling up our sleeves and getting under the hood of Natural Thoughts. So let's dig into implementation details that both CTOs and product owners can take straight to their roadmaps.
First stop is data plumbing. Remember, they start with 2.8 million natural reasoning prompts, but only 500,000 make it to training, so the extraction pipeline must support streaming deduplication. We used an Apache Beam job with MinHash on 8-gram shingles to cut overlap by 37% before any fine filtering. And right after that, the annotation stage kicks in. 3 prompts per example: topic tagging, reasoning strategy tagging, and verbosity scoring. We ran these prompts through a frozen 70B model with temperature 0.0 to avoid hallucinated labels, cached every response, then used a simple majority vote across 2 random reannotations to push label consistency to 93%.
Building on that, we pipe those annotations into HDB scan clustering of the sentence embeddings. Quick tip: if you leverage FICE with IVFPQ, you can cluster 500K items in under 11 minutes on a single A100, which beats a vanilla Scikit-flow by an order of magnitude.
For the business crowd, think of clustering as segmenting customers. Here we're segmenting reasoning phenomena so we don't train 5 replicas of the same mental pattern. Saves compute, boosts generalization.
Exactly. And from a governance lens, each selected cluster can be audited. Our legal team loved that we could sample a cluster labeled self-verification plus chain pruning and review only 1% of cases for red flags.
Great segue. Let's talk curriculum. How do we actually mix System 1 and System 2 once we've got these annotated examples?
Implementation-wise, it's as simple as adding a Boolean flag in the JSON include thoughts true-false and using a conditional template. During data loader time, we randomly route according to P-System2 or the difficulty heuristic. No code change inside the model.
The magic is in the prompts. For System 2, we prepend think tokens and a budget hint, e.g., use about K words. For System 1, we delete everything between think in the teacher output and leave only the answer. That means your tokenizer sees drastically shorter sequences for easy cases, so your training step time shrinks 25 to 30%.
And the optimizer matters. Adam W with a flat LR schedule at 2E5 was used, but we found that switching to Lion with decoupled weight decay shaved another 7% off wall clock by stabilizing long sequence gradients.
Quick cost metric. Training 100K natural thoughts samples on 32 H200s cost us roughly 8.4K. The same run on 500K tallied $38K, but we saved 120K annually at inference, so payback was 2 months.
Love concrete numbers. Now, for product teams wanting QA guardrails, how does disagreement-based sampling get wired in?
We run both teacher models batchwise, grab final answers, then send the pair plus the question into a smaller evaluator LLM. If evaluator says answers differ, we write an is-hard true tag. That's it. We store scores in a DuckDB, so downstream selection queries are lightning fast.
A small nuance. We threshold on evaluator confidence above 0.85 to avoid false positives. Anything ambiguous falls back to random sampling, so we don't starve the corpus. I'd add a counterpoint. Over-reliance on disagreement can bias toward edge case questions. We noticed a skew to arcane physics, so we blended in 10% purely random picks to keep domain breadth.
And that matters commercially. Our insurance chatbot benefited from those randoms because customers ask eclectic stuff like, can I insure a drone fleet for crop dusting, which wasn't in the hard science clusters.
Switching gears to training logistics, sequence length was 16K. Most orgs don't have that. What's the pragmatic workaround?
Gradient checkpointing plus flash attention 2. If you cap at 8K tokens and chunk COTS with a Sentinel token split, you still retain 92% of the reasoning path fidelity while having memory.
We did exactly that and fit the run on 80 gig A100s instead of 141 gig H200s, dropping rental costs by 45%.
Also, token bucket batching, group samples by similar lengths so you don't pad to max. It boosted effective throughput from 380K to 510K tokens per step in our trials.
Excellent. Let's get even more tactical. How do you log and monitor reasoning strategy diversity during live training?
Lightweight trick. Every 2K steps, sample 128 training examples, run the same strategy annotator on the student's outputs, compute Shannon entropy across strategies, and plot against wall clock. A rising curve signals growing diversity. Flattening indicates you're overfitting specific patterns. We pipe those metrics into Prometheus and set an alert. If diversity entropy drops below 2.3 bits for 3 eval windows, trigger early stopping, or inject a fresh batch of hard questions.
That's analogous to managing a stock portfolio. You don't want concentration risk.
On the business application front, can we walk through a second concrete use case, say retail demand forecasting?
Sure. A major grocery chain fine-tuned a 7B model with 50K natural thoughts items biased toward models disagree. They fed in promotion schedules and local events, asked the model to reason whether to accelerate restocking. Mixed distillation cut response tokens by 60%, letting them run the model on an on-prem T4 cluster. Stockout incidents fell 9% month over month.
And note the strategic kicker. They didn't need to expose proprietary sales data to a third-party cloud because the model fit on-prem, satisfying compliance.
Very compelling. Let's address a curveball. What happens when your domain is heavy on images or code snippets?
For multimodal, you can still leverage natural thoughts as teacher text scaffold. Generate text-only COTs that reference latent image concepts, the pixel histogram suggests, then pair with vision encodings. In our robotics division, that hybrid approach improved success grasp rates by 5%.
For code, the team at Meta already showed LLMs extract reasoning primitives like divide and conquer or memoization. Tag those as strategies and you can replicate the same pipeline, but swap in tokenizers that preserve whitespace and indentation. One caveat: token bloat. Code traces can hit 25K tokens, so consider segment-level distillation. Distill each logical block's reasoning separately, then stitch answers.
Time for a lightning round on pitfalls. 1 sentence each. Biggest mistake to avoid.
Don't trust noisy verbosity scores. Calibrate them with a held-out human set, or you'll downsample gold traces.
Avoid shutting off gradient on question tokens. Leaving them masked cost us 2 accuracy points. Let the model see full context.
Skip manual cluster counts. Auto-tune HDB scan min cluster size. Hard coding kills recall.
Forgetting eTag caching on teacher outputs will triple your annotation bill. Been there.
And finally, don't present token savings to leadership without tying them to business KPIs. Savings alone won't sell investment.
Wise words. To quote Drucker again, there is nothing so useless as doing efficiently that which should not be done at all. With natural thoughts, we're learning to do the right reasoning efficiently. Thanks everyone for the deep dive. Listeners, implement these tips and let the ROI speak for itself. Until next episode, keep that reasoning sharp and your token counts lean. Fantastic run-through. Team, before we sign off, let's crystallize the main takeaways so listeners can screenshot the mental whiteboard.
Top of the list. Scale still matters, but only when you scale the right slices. Diverse reasoning strategies beat topic diversity 3-to-1 on downstream lift. So budget your crawl toward cognitive coverage, not just corpus size. Technically, annotation is no longer a sunk cost. Treat it as an index. Once you cluster on strategies and difficulty, you can yank fresh subsets for every experiment without touching the raw 2.8M prompts again.
And remember the contrarian gem. Mixed System 1, System 2 distillation shifts the efficiency-accuracy frontier more than swapping optimizers or doubling parameters. It's the Occam's razor of training recipes.
From the boardroom view, those efficiency gains convert into hard dollars. One retail pilot shaved 60% inference tokens and paid back infra spend in 8 weeks. So this isn't a science fair project, it's EBITDA.
Governance got a nod too. Auditable clusters mean compliance teams can spot check by concept, slashing legal review time. That's a hidden but massive accelerator for regulated industries.
Let's not forget risks. Over-indexing on disagreement can suck the model into Trivia Alley, and verbosity scores need calibration, or you'll toss out gold. Treat heuristics as guardrails, not gospel.
Implementation cheat sheet. Use FICE-backed HDB scan. Set min cluster size via grid search, enable flash attention to, and flag include thoughts at load time. Everything else is plumbing.
Quick heuristic for scheduling. 70% of your GPU hours on 100K Diverse strategy samples gets you 90% of the gains. The 80-20 rule with a safety margin.
Future-proofing? Plug the same pipeline into multimodal or code. Just swap the annotator prompt and tokenizer. The scaffolding stays rock solid.
Strategically, that means you can iterate product verticals, retail today, robotics tomorrow, without a brand new data engine every quarter.
To paraphrase Deming, without data, you're just another person with an opinion. Natural Thoughts gives you data about thinking itself.
Perfect quote. So the headline: curate reasoning, blend System 1 and System 2, monitor diversity entropy, and tie every token to a business metric. That's the playbook. Big thanks to all our experts and to you, our audience. Apply these insights, drop us your war stories, and we'll dissect them in a future episode. Until then, keep experimenting and keep reasoning forward.